Hi, everyone. I am Brandy Quam, your host for our LST's first ever roundtable talk. I am the Director of Interagency Solutions here at LST. And today we're going to be exploring the transformative potential of advanced air mobility and shaping everyday life. Our experts here with me are going to delve into how AAM technologies promise to revolutionize urban air mobility by alleviating congestion and connecting remote areas. And not just that, we've also seen a ton of federal investments as of late, everything from R&D to prototyping of the vehicles and technologies themselves, as well as planning of the airspace and strategy, as we saw in the 2022 AAM Coordination and Leadership Act. In our discussion today and this afternoon, we're going to highlight how AAM is pivotal or plays a pivotal role in emergency response and medical transport scenarios, its ability to foster community development, and its impacts on delivery services across the United States. Ultimately, our conversation is going to help paint a picture of the future of AAM as it emerges, and we'll show it that it's a catalyst for positive change. It promises enhanced connectivity and improved quality of life, as well as sustainable urban future. Joining me here today, we have Pat Summersall, Director of Future Operations, as well as Kristen Beverly, the VP for ATM Services, and Rich Jalen, Executive ATM Services. Gentlemen, thank you for joining me.
Thank you.
All right, let's start at the beginning. Pat, we'll talk with you first. If you follow any one of the agencies, Department of Transportation, FAA, DOD, NASA, AAM will come up in conversation. So we hear it so often and interchangeably. I'm just wondering if you could help provide for us a definition. What is advanced air mobility, AAM?
Sure. The way that we read about AAM and advanced air mobility, it is an emerging aviation ecosystem that leverages the new aircraft technologies, and an array of innovative changes to provide the opportunity for more efficient, more sustainable, and more equitable options for transportation. Numerous people, you probably heard them talk about my Uber ride, my Uber air taxi. That's just one aspect of AAM that we hear about. The FAA quote is AAM is a transportation system that moves people and property between airports, between air by air, between 2 points, man. In the United States, using aircraft with advanced technologies, including electric aircraft or electric vertical takeoff and landing aircraft in both controlled and uncontrolled spaces. So it's not just an battery-powered aircraft, it's also the encompassing and complementing technologies for avionics, systems to detect and avoid, different aspects that improve the overall safety of flying and improving the efficiency of the airspace utilization. The AAM initiative aims to develop an air transportation system that moves people and cargo between local, regional, interregional, and urban locations not previously served or underserved by aviation, using innovative aircraft technologies and operations. While this is all going on and it all sounds really good, there are some initiatives that are very prominent right now. One of those is it was created and it's called Innovate 28. It's a joint government and industry initiative that will culminate in integrated AAM operations at one or more key site locations by the 2028 timeframe. One of those areas is in the Los Angeles area, coinciding with the Olympics that are slated for 2028. So who knows, you may be able to get off the airplane at the airport and ride an air taxi Uber to your destination at the Olympics. Brandy, back to you.
Excellent. Thank you, Pat. Yes, I, for one, am looking forward to a vertiport on top of the Spy Museum right outside of LS Technologies to help us with that DC traffic. Let's move on to talk about the technical versus real life applications of AAM, the applications as well as the implications. Anyone in the panel?
So I'll offer a couple of them, Brandy. First of all, I'd like to piggyback on Pat's description. For a lot of the folks, the terms that are used, you hear AAM a lot, but also there's UTM and all. And here's the distinction. The smaller one, and we're not really going to talk a lot about this one, but so that people understand there. When it was brought up, the deliveries from Amazon or from Google or what have you, those are generally your small UASs. Those are going to be, so the functions and real life applications for those, everyone's talking about. I'm going to get my package, but there are also a wide range of those as well. I'll give you one example. There was a storm came through North Carolina on the Outer Banks, and one of the roofers went to the coastal areas. He set his truck outside. He took a small drone with the high density cameras, went across an entire row of houses. When I was talking to him, he did like half a dozen or a dozen homes, inspected the roofs from his truck. The thing was up there, took photos. He had the addresses of the people there. He attached the photos for the ones where there was damage. And in the course of 2 hours, he had inspected and sent out offers to do work for 4 or 5 people, where if he had had to do it previously, putting up a ladder, going around, doing that, getting down, he could not have done that. So the efficiency gains there in 2 hours, and that's just one example. There are a range of them that, as Pat said, part of this, and everybody talks about the cargo, but the small UASs are those that are going to be under 55 pounds. So you're going to have a very limited payload for those types of things, but there are many uses. Those are not the ones we're talking about here. The next one, when people generally talk about AAM, some of those people will see, as Pat said, it's transport. Think of it as taxi-like, Uber-like, what have you. You would be able to, those are larger, and that's what differentiates. Technically, they're all, in the environment, but UTM from AAM, and those are the larger ones because humans can be on board. Clearly, you can't put a human on board of something that's 55 pounds or less. Maybe a small child, but I don't think you really want to try that. But in the case of AAM, so we talk about the transport of people. There will be transport potentially of larger cargo, as Pat had talked about. But the other part that some of it, in fact, we'll stay with that for one more moment. For a regular individual, just for time in a daily, imagine the surface congestion and you're in downtown DC and you have a flight out of Dulles. If it's the afternoon and you have to get out on 66 and 267 to try and get to Dulles, it's a problem, especially a late meeting. So the costs of it, depending on how the market wears out, you could actually buy back a whole bunch of time. Okay, so that's one that's there. Back to the one that as well for, yes, if you're going to go to LA, or you're going to go for the Olympics, or if you're going to a concert, where even if you do an Uber, you're still in the surface congestion, you still get to the gate, you still have to walk, to wherever. So in this case here, you wouldn't have to take your car, you wouldn't have to do that. You can leave from some other place to get there, so on and so forth. But even more critically, because of the larger vehicles, they will begin to offer the following opportunities. Imagine a heart attack at home, or you need something, not to put out a fire, but what you need is emergency rescue, okay? First responders in terms of heart, something like that. They can turn around and they can be there because you see them on the road. How many people have seen the people on the road where the sirens are coming up behind you and the person doesn't pull off to the right? And so they get balled up, they can't get through, or they're slowing down because they have to get through the intersection and the concern is about cross traffic. You could get a paramedic to a location much more rapidly. Okay, they could bring with them, what they need. Or if it turns out that they get there and they find out that you need a specialized piece of equipment, we're not talking about an AFib that they have on hand, but you need something special. A hospital could turn around and discharge that, and again, it would be their lickety split. So those types of real world emergency events will improve the general life and response of the population at large, where if you're in crisis or something's there, hikers that are in somewhere else who injure themselves, it is possible that these things can be programmed to go to that particular, if you have your iPhone and you can drop a pin, they can follow that pin to you, and they've already talked about it, that an unmanned, uncrewed vehicle goes to where that injured hiker is. They load the people that are there, or the individual themselves, loads themselves onto the vehicle, and then the vehicle takes them back out of. So there are tremendous opportunities. There are a range of others, but this one here I think is critically important, because once you get to the larger size that AAM has, the quality of life and health and response for people in general. So I would just wanted to offer that one.
Thank you, Rich. Excellent examples. And Kristen, did you want to add anything to that? Talk maybe about the disaster response applications, or
Yeah, no, I can probably there are, yes, as Rich said, there's myriad applications to this, and you'll see it, I think, more and more in people's lives as we carry forward. The FAA has been putting exemptions in place for increasing the footprint of drones in operation around us. Just a few weeks ago, they allowed additional beyond visual line of sight operations. Up till recently, there needed to be folks watching out for these drones as they went by, to always retain visual line of sight on any sort of operation. But more and more, they are giving exemptions to allow these operators to operate beyond visual line of sight. 120 miles are some of these cargo delivery plans now that are possible, given what the FAA has made sure is mitigated in terms of risk and safety and those. Some of the things, though, that, along with, how this impacts people, not only, the things that are awesome, the ability to deliver, medical supplies, in emergencies, or do search and rescue, or coordinate wildfire, operations. And even in agriculture, there are targeted approaches to applying pesticides or fertilizers across vast arrays of fields in very, very efficient ways using these kinds of drone operations. Even aerial photography, are places where drones are making an enormous impact. But there are also consequences, right? There are issues around sound pollution and mitigating that. You have these operations potentially operating at low altitudes that conceivably would affect the environment from that perspective. You also have privacy, concerns. You have, folks with drones delivering packages flying over their backyards. What are the implications associated with that? So people's lives are going to be affected by these kinds of things. Recently, early this month, there was an article in the paper about an arrest that was made, where a drone operator was dropping green dye packs into people's pools using a drone. And so trying to track down that mischief to the operator is something that we also want to keep in our minds, and in how we identify those operations, be able to identify those folks and be able to trace that back to the operator that's using them in those less than awesome cases. So a lot going on, all of it, really things that I think will likely have more and more of an impact on people's lives.
absolutely. And that kind of, you started to touch on my next question, which is related to, we're aware that AAM is gaining in momentum. There are challenges associated with it. What do you all see? And maybe you could talk about it a little bit more, the challenges and opportunities aligning with regulations and standards associated with AAM safety and efficient operations.
So I'll offer a couple thoughts, but I did want to offer one back to Kristen's thing. For those who are watching, if you are interested, the reference that Kristen was making, or one of them, was to Zipline. And if you go online, Zipline has been working for several years in Africa. They have thousands and thousands of flights that they have undertaken, delivering medicine and blood. Now, there in Africa, it is not surface congestion, it's lack of surface roads and things like that. But if you go to YouTube, you can watch their launch and their recovery procedures, which are really quite interesting for the way, and each implementation will be different. But for some of theirs, when they were done, is they launch them from what looks like a giant slingshot or what have you. But when they recover, they recover it to a wire. So it's a hook. It hangs up in the air, and when it comes and they capture it, it's quite there. So if you go to YouTube, you can look at that one. So backing up on what Kristen had said, these things are going out there. They're being tested, and now that you are moving things into the States for beyond visual line of sight, As for the challenges, I would offer a couple of them, especially in the regulatory environment. One of them, people are focused right now on the ones about, well, okay, what are the regulations? As Kristen said, you're going to have these questions of, you have more vehicles in the air, and who has the right of way for this, and how do you ensure these don't run into those, and there are a variety of those. And people have talked about those, along with privacy, noise, things like that. Incidentally, they have done a significant amount of work. I can't remember if it was Google or Amazon. Excuse me. I think it was Google. They have put an entire engineering team to work on the geometry of their propellers that they use for their VTOLs to reduce noise in the frequency that is actually human hearing. And so it is a very sensitive topic, and people are aware of it. So it is a challenge, and people are addressing it. One of the ones that is somewhat buried in the very beginning, even with the rules and everything else, we all talked about the many uses. Now, clearly, if you have a smaller UAS that's not transporting people, they'll be probably somewhat a little easier with regard to, just how sturdy and all of those things. But let's just stay with the AAM ones that Pat had talked to. They are discussing this like it's going to be like Uber. It's going to be like your car. There will be, so in 2022, just the F-150, Ford Motor Company manufactured 1.9 million Ford F-150s. Tesla's Model Y, they produce on the order of something in the neighborhood of, I think it's 350,000 a year. Yeah, about 350,000 a year. They do that, but when you create an airframe, the requirements, and this is in any of the large, complex, developed nations, the requirements for tracking of parts, that those parts have to be certified, your processes have to be certified, the ops manuals and ops specs have to be. Boeing and Airbus each turn out a little under 100 airframes a year.
Yeah.
Because all of the technical wizardry, but it's also the tracking of all of those things. So you have to consider, okay, yes, when they get it built, in order to get it certified to get AAM aircraft, okay, into the air, you have this mix between a production line that's running 1.9 million a year versus one that does under 100. Somewhere in between, this is going to be, back to your regulatory and certification question, Brandy, that is going to be a major challenge to say that, okay, how do these production lines get up to speed and yet meet the safety standards and certification requirements that the AVS and the safety organization in the FAA require to assure the public at large that these things are safe, because we're going to put people on them. And one of the things they are very concerned about, the manufacturing all, is they themselves are concerned about safety, because just like Tesla, I'm sure everyone's seen it, it hits the news whenever a Tesla for any reason runs into something. People, the full service driving, self-driving, and it ran into the fire truck, and so on and so forth. It is expected that any of these AAM vehicles, and there will be mistakes. I mean, this is a new technology. Putting it up in the air, which kind of leads me into my last part for this one, is we have no idea how these things are really going to be employed when you start getting to scale. And we need to be humble about that. And the reason that I say that is there are unintended consequences, and we don't foresee the future well. The famous quote, I think, Joe DiMaggio, it's really hard to predict, especially the future. And in the case IBM, when they manufactured the first mainframe, I think it was the CEO of IBM estimated that he didn't see a need for more than a dozen mainframes worldwide with regard to the mainframes. Now, in our case, you're going to get unintended consequences when you start putting these things in the air. Once you get over all these challenges and you start getting past, some of them will be tremendously beneficial. There will be whole jobs that change their function because of it, because they're able to do it. But we also have to be cognizant that there are things that are going to change that we hadn't even seen. And I will give you an operational example. For those who are not aware, there's a thing called runway status lights. The runways lights themselves, I'm sorry. in order to be environmentally conscious, to lower power and everything else, years ago, they took on and said, well, what if we change those massive incandescent lights that sit on the sides of the runways with LEDs? We'll save power, we'll save environment, we'll save our carbon footprint, the whole thing. And they did. And you can put them, you could put them down and so on and so forth. This was a great idea. Then they deployed a couple of them. Now they tested them, they did all this, but a failure of imagination. What happened? It turns out that the aircraft for years had been using cutting edge technology in low visibility operations, fog and rain and things like that, which think of it, enhanced night vision. Well, the frequencies that it used didn't pick up the LED lights. So now you had aircraft trying to operate in low vis, which they were qualified for because the regulatory certifications were there. But if you went into an airport that had these type of lights, it couldn't see them. In addition to which, the LED lights didn't produce enough heat that if it snowed, they couldn't melt the snow, where the incandescents did. And, I don't know if it was a joke or not, but they did go in some places and put little heaters in the LED lights so that they could melt the snow so you wouldn't have to send a person out to brush off the top of the thing. So these were unintended consequences that did not have been foreseen. If you actually sat there, and imagined, so once again, it was a failure of imagination. The other part is, I would caution that people don't need to be worried about this, in the sense there will be these types of challenges and things like that. But this isn't going to, we will eventually probably be at something similar to the Jetsons, but on the Jetsons, when we see them all going around, I never saw any cars in the Jetsons. Everyone's flying. There were no surface cars, as I recall, when I saw the Jetsons. That's not how the real world operates. And the reason that is true is that right now, well, as of 2019, it's probably still true now, but I haven't validated it. There were on the order of 24 beacons in operation, maintained by the federal government in Montana. These beacons, they've been upgraded all through the years, but they were installed in the 1920s. They were installed originally to support airmail service delivery from New York to San Francisco, and then they expanded from there. But they continue to operate in Montana in some of these remote locations because they're the right technical solution for the right challenge. And so some of the challenges for these things are going to be identifying, okay, where is it proper to use and where is it not? And you have to be careful that, if all you have is a hammer, everything looks like a nail. And so in this case here, that's not the way, and it's going to increase the complexity of what's out there. So I will offer those as some of the higher order challenges that'll be there. Some of the others may wish to share different ones.
Thank you, Rich. So yes, it's very exciting to look at a billion-dollar industry, but no crystal ball for the near term, and probably likely a lot of starts and stops technologically as we transform for sure. Kristen or Pat, did you have anything to add to that, to those opportunities, challenges?
So one of the things that Rich brought up was the production of the F-150 versus Airbus. And just a couple of days ago, Joby just announced a new manufacturing plant deal in Ohio. And they're looking at upwards of 500 aircraft per year. So that's pretty impressive when you think about all the logistics behind what Rich talked about. So it'll be interesting to watch the certification of all these activities and all the increasing utilization of that type of aircraft. And you think about the number of them out there, you start increasing that, then we start looking at the challenges of our airspace utilization and how that increase in activity, especially in the urban environments, are going to need the support of advanced avionics and communications capabilities and potentially rethinking how we manage those aircraft, manage the operations, and integrate them into the already existing fleet of aircraft that are out there that in some of the 1920 built aircraft are still flying out there. So, we have to span generations of types of aircraft as well. So that's one of the challenges just for the National Airspace System is absorption of the new technologies. And that's not even touching on the smaller AAM environment of UTM.
Absolutely. And I think both of you actually spoke to the economic impact with the new plant pad there. So that's absolutely one, sustainable transportation, economic impact, but also the challenges between legacy systems and capabilities and where we're going. And also, Rich, I don't know if there were even streets in the Jetsons. I think all of their houses were elevated, and so they didn't have.
Everybody lived in high-rise
I
condos.
believe so. I don't remember exactly, but all right. So thank you both so much for that. So I want to move on to one more question or two more questions, really. Um, LS Technologies, we are at the table and we are involved in keeping an eye, and we obviously have AAM experts. What is our role in all of this now and maybe in the future?
So maybe piggybacking off of what Rich was saying, and even Pat was saying, there are an awful lot of challenges. There is a learning curve associated with these things as the technologies are being developed, as the operations are being assessed, as we are looking at integrating these capabilities into the National Airspace System, and ensuring the exceptional safety of the systems that we have in place, of the airspace. There is obviously a real need to attack these things in a systematic way, to really think through a lot of those implications, a lot of the challenges as they come in. And there's a tremendous amount that we will learn as we go, but there's also a lot that we already identify as areas, to explore. And so part of what we do is we bring, operations experts like Pat and Rich and, a bunch of other folks, engineers, analysts, technologists, all of these various different folks with an ability to kind of see into that future, maybe a little bit, to bring to bear that talent, that perspective, those kinds of ideas and those questions, to develop use cases, to come up with concepts of operations, to really work through some of the engineering challenges, to explore and validate, potential solutions, and to come up with recommendations and guidance as the various different entities, both on the industry side but on the government side, are working towards making sure that things like Innovate 28 and air taxis to the Olympics in 2028 are going to be possible. How do we implement that? So we are involved in the development of concepts, the performance of engineering work, even kind of the invention of the information architecture to support those kinds of things at a very fundamental level. And we get to see some of this in action as we support demonstrations of capability and help them stand up various different test beds and examples of these kinds of operations, so that we can learn more and incorporate that into the thinking, and once again iterate so that we continue to move forward into that future with as much knowledge as we can as part of the ongoing effort.
So I'd like to offer an extension of that, building on what Kristen offered. All of the things that Kristen said we do, but for the folks in LST, should also recognize that we don't just support the FAA in terms of this. So in the support for the FAA, and even though the FAA and our support, as Kristen pointed out, is trying to see a little bit into the future, it is tempered by what's real. Okay, we have operations people and engineering people who are familiar with the National Airspace System now. What does the infrastructure look like? What are those information requirements and how do you get there? Okay, so our view of the future and evolutionary steps is tempered by knowing you don't have a clean sheet of paper. However, we also support NASA, and NASA tries to start with a clean sheet of paper. And so the same people that we have there, and we participate with NASA in saying, well, what about this? Okay, and so not just to bring imagination to the table, but also imagination with how is that going to work with, to Pat's point, we have airframe. The B-52 is now going through an upgrade cycle. It's already been in the air 60 years. And when they get done, it's going to fly for another 25 or 30. Okay? Those vehicles, how is this going to work in that kind of an environment? Because NASA and where we are, everybody is, oh, it's a clean sheet of paper. They don't worry about what's out there today. But clearly, NASA doesn't do revolution well. The National Airspace System does evolution, not revolution. So we support NASA in trying to think up, okay, are there things that you can get to in the future that don't defy gravity, but are viable? And we have supported NASA across the range of those things which are flying above 60,000 feet, which ETM. We also have supported the Department of Homeland Security and also DoD. DoD is very interested in real world applications. Yes, they like NASA and the far out stuff, but they want to know how it affects them. So to answer your question, Brandy, about what is our role, LST's role is we have subject matter experts around the holistic ecosystem that is UASs, all the way from those who operate above 60,000 feet all the way down to those that are operating below 400 feet. And so for each of the agencies, they have different mission objectives and mission spaces. Our role in some of these, well, across them, is to help them or support them in their mission space, knowing what we know about all of the other work that's going on, because the NASA is not standing still. While any one of them is trying to plan to do something, you said, well, you need to know that may be good what you're planning, but the FAA is going to make that go away in 5 years. So you may want to rethink that. So our role is to help across the organizations that we support to leverage and bring together a holistic approach to the National Airspace System within the mission space that each of these organizations operate.
Thanks to you both. That's exciting. I love to hear that we are full gamut across the interagency, providing support in this technology and capability area. Very exciting. Pat, I started with you. I think I'll wrap up with you. It's a little bit unfair since we can't predict the future, but if we could, what does the future look like? And how is AAM being rolled out to the public?
So I think the future looks pretty intriguing. And I say intriguing because we don't necessarily know exactly how it's going to play out. We look at just the impact that the UASs have had, like what Rich was talking about earlier, surveying storm damage and coming up with what needs to be done and estimates for people that you can go right to your insurance company then and say, oh, I got an estimate and here's some pictures on what the damage is. You don't have to wait for that evaluator to come out and they have a visual, so that's happening now. But as we move forward, and if the economies of scale, plans roll out and we get the productions and the acceptance and the thought of being able to take my air taxi from Lake Anna to right up here to DC to come to work and commute back, and the simplicity of not having to deal with congestion and all the other activities, that's intriguing. That intrigues me because the cost model needs to come down. That's done by production. And when you see production numbers like what Joby's talking about and the number of different ones out there that are on the table to be into production, it kind of reminds me of the heyday of small aviation, when you had how many thousands of small Cessnas that were being produced. That was a big shift in the pilot training and the flexibility and the ability to move around. Now we're shifting into that next realm where that mobility and access, rural access, remote access is becoming more cost effective and efficient and simpler. The simplicity of and trust of the automation to fly the systems that are very complex, but they fly themselves practically. So you can learn to fly a small UAM, electric motorized UAM, in an hour. that'll take you, because it's all been simplified to that input and management and the system management system. So it's very exciting to see where it's going. In the thought of, some of the other activities of the high altitude and the communication side that we didn't even touch on, and the cargo delivery. My house in Lake Anna is very remote. I'm thinking I might be a good spot now. I can get Amazon to drop off, and maybe get Whole Foods to bring my milk over. Hey, there we go. I may not have to leave the house. I can just go stay out on the water. So that's exciting for me, and very, like I say, very intriguing to see how we move forward and all the opportunities that are out there for open thinking of what the possibilities are for the application.
Yeah, it definitely changes future of work a little bit too. So yes, Lake Anna to Washington, D.C. in a few minutes. So gentlemen, thank you so much, all three of you. Any last words or comments? And also thank you, Mariama, for making this first roundtable possible. We really appreciate you. Any last AAM words?
Thank you for having us here.
Wonderful.
I would just offer that probably as the song from Timbuk 3 was, the future is so bright, we're probably going to have to wear shades.
Thank you, gentlemen. Have a great day.
Bye-bye.